All right, welcome everybody. Today we're going to talk about lesson number 48, and this is all about evaluating definite integrals using the FTC, and the FTC is short for the fundamental theorem of calculus. Just to kind of reorient you as to where we left off, in lesson number 47, you were investigating how to find area underneath a curve. You were using Riemann sums, which means you're going to draw a series of rectangles, and you're going to try to best estimate that area under the curve. You can either use a left endpoint or a right endpoint or a midpoint, and you're going to try to get as close as possible to the area under the curve. The ultimate conclusion that we developed at the end of the lesson was that if you want to find the area under the curve, you can do so by using a definite integral. And again, a definite integral means you know exactly where you're starting and exactly where you're ending. Now, a little bit of a qualifier as far as when does that definite integral actually represent the total area. All the problems that you've done so far, all of the shaded region, all of the area under the curve was entirely positive. Turns out that there are some things we have to consider if the region is not entirely positive, but we're going to go ahead and save that for tomorrow. And today we're just going to focus on the mechanics. So again, what is the fundamental theorem of calculus? Well, here's what it says. If a function f is continuous on the closed interval from a to b, and big F is an antiderivative of little f on that same interval, a to b, then the fundamental theorem of calculus says this. If you are integrating some function from a to b, and again, dx is the variable of integration, so it just has to be there, you're going to go ahead and integrate little f, and you're going to get big F, and you're going to evaluate it at each of those bounds. You're always going to plug the upper bound in first. You're always going to plug the lower bound in second, and you are always going to subtract, keeping in mind that if there's multiple pieces to the first calculation and there are multiple pieces to the second calculation, you want to make sure to use parentheses accordingly. So the fundamental theorem of calculus, I just want to point out here, it is on your formula sheet. Remember, these are all of your integration formulas, which you're going to continue to need for the remainder of the chapter. And then the fundamental theorem of calculus is right here at the top of the right-hand side. So just make sure you're aware of that. As we go back to the notes here for a second, something that I want to point out here. So the answer to a definite integral is a number. So again, a definite integral means you have to start somewhere and end somewhere. We're going to say start at A and end at B. And the answer to a definite integral is always a number. Remember, that's different from all the previous examples we've done, which were indefinite integrals, where you ended those all with a plus c. So whenever you're calculating one of these definite integrals using the fundamental theorem of calculus, your answer is always a number. As far as what that number actually represents, we're going to get more in depth with that tomorrow. But for now, we're just going to go ahead and practice the mechanics. Before we practice the mechanics, there's one other thing I want to just review quickly. I would assume that at this point, you all have a graphing calculator of some kind, whether it's a TI-83 or a TI-84. When you're doing these definite integrals, you do have a bit of a throwback to some of the functions you might not have used in a while. So I just want to remind you of a couple of things. Let's say you're trying to do the square root of something. Hopefully you remember that the square root is found by doing second the x squared button. The square root of, let's say, 8, you could go ahead and plug that in, and it will give you a decimal answer. Let's say you wanted to find the cube root of 8. There are two ways to do that on the calculator. The first way is if you press math, and then you go down to the cube root option. You can then take the cube root of anything that you like. In this case, we're going to do the cube root of 8, and that's going to give you an answer of 2. Remember that another way to find the cube root of 8 would be to do 8 to the 1/3 power. So if you're doing 8 to the 1/3, use parentheses, then use the caret key. Use another set of parentheses for your 1/3, and to plug in 1/3, you're just going to do 1 divided by 3, and then you're going to hit enter, and of course, you're going to get the same answer. Let's say you wanted to do a 4th root or a 5th root. If you're trying to do that, you can say the 1/5 power or the 1/4 power. And just so you know, you could do the 2/3 power or the -1/2 power. Those are all still options, assuming you use the correct parentheses and the correct caret key. Something else you may not remember, let's say you wanted to take the fourth root of something, you're going to go ahead and start by pressing 4. Then if you're going to press that math key, and then if you scroll down to the xth root option, if you have a TI-84 or better, it will automatically make the 4 small up in the index. If you don't, it might just stay a full-size 4, but either way, your calculator will know that you're taking the fourth root. Let's say we pick something we know the fourth root of, like 81, press enter, and it will give you a value. It's very possible when you're doing the FTC that you're not going to get these nice integer values, but I did just want to remind you where you could find those buttons in case you need them. Something else, we are going to be asked to use our old friends, the trig functions. So obviously the sine, the cosine, and the tangent are there right there in the middle. Remember, if you wanted to do the cosecant, you have to do 1 over sine. If you wanted to do the cotangent, you have to do 1 over tan. And then you have to check your mode. When it comes to evaluating using trig functions, we generally have pi over 6 and pi over 2 and things that have pi's, which means you should probably be in radian mode. So you're going to want to check your fourth option down. And if you are not in radian mode, you're probably going to want to go ahead and get into it. So now that you've set up your calculator and now that we've reminded ourselves of some of those important buttons, we should be good to go. So here in number 1, we're going to evaluate this definite integral, which means my answer should be a number. So the first thing you're going to do is you're going to integrate just like we've been doing. 4x cubed minus 3x squared. If there was any algebra or any rewriting to be done, you would do it. Looks like we're pretty safe here. So we're going to leave the 4. We're going to go ahead and integrate the x cubed. So we're going to raise to the 1 higher power, which is 4, divided by that power. Then minus 3, we're going to go ahead and take the squared to the 1 higher power, divided by that power. Then we're going to go ahead and simplify. So when we simplify, we're going to get x to the 4th minus x to the 3rd. And then here's the notation that we tend to use. You're then going to draw a vertical line, and you're going to put the lower limit of integration on the bottom, and you're going to put the upper limit on the top. That means that line there is just kind of the fancy way of saying, I have done the integration, and now I'm going to evaluate it. So again, according to the fundamental theorem of calculus, after you have evaluated it, or after you have integrated it, you're going to start by plugging in the top number, which is 3. So in this equation, after you integrate, everywhere there's an x, you're going to put a 3. So 3 to the 4th is 81, minus 3 cubed is 27. I'm going to go ahead and put that in 1 parentheses. Then it's always a minus between. Now you're going to go ahead and put your lower limit of integration in. So that is going to be 1 to the 4th, which is 1, minus 1 cubed, which is also 1. And now you're going to go ahead and calculate. So whether you do each parentheses first and then calculate from there, whether you distribute the minus, you're going to kind of get into a routine as you go in terms of what is the best way to go about it. I'm going to do it 1 parentheses at a time. So 81 minus 27, that's going to give me a 54. Minus 1 minus 1 is going to give me a 0. And 54 minus 0 is 54. So that technically is your first time you're doing the whole problem from start to finish using the fundamental theorem of calculus. Again, integrate, plug in the upper limit of integration, always subtract, plug in the lower limit of integration, and your answer should always be a number. It could be a big number, a small number, a positive number, 0, a decimal, all kinds of things. And again, in terms of what that number actually means, it's a little bit nuanced, so we're going to save that for tomorrow. So for today, all you have to master is the algebraic component to it. So let's go ahead and do a couple of more, bunch more. So here in number 2, you're now going to integrate from -2 to -1. So again, feel free to realize here that you can do it for negative values as well. Hopefully you realize that -1 is larger than -2, which is why that number is on the top. You're going to go ahead and start by integrating whatever's inside. And in order to do that, I'm going to go ahead and first do a rewrite step. So if I'm doing the rewrite step, I'm going to copy my integration. I'm going to copy my limits. And I'm going to go ahead and rewrite this as x to the first minus x to the -2. So all I've done so far is the rewrite step. I haven't actually done any integration. That's going to go ahead and come next. So I'm going to integrate x to the first as x squared over 2 minus When I take x to the -2 to the 1 higher power, that's going to be -1, all divided by -1. I'm going to do a little bit of simplifying, so that's going to give me x squared over 2. The double negative is going to turn into a positive, and then I'm going to rewrite x to the -1 as 1 over x. Once you've actually done the integration, remember the fancy way of saying you know you're evaluating is to write that vertical line and to remind yourself you're evaluating it from what to what. You're always going to start by plugging in the top number first, and again, using parentheses where necessary. So you're going to go ahead and plug in that -1. So -1 squared is going to be +1 over 2, plus 1 over -1 is -1. Then remember, you're always doing a minus, and now you're going to go ahead and plug in the bottom number. So as you square a -2, you get a +4 over 2. Plus 1 over -2 is -1/2. Again, you can simplify it in one step. You can simplify it in two steps. It's really kind of up to you. So if I simplify the black first, 1/2 plus -1, that's going to give me -1/2. Then minus 4 over 2 is 2. 2 minus 1/2 is 1.5. So -1/2, which is -0.5, minus 1.5 is going to give me final answer of -2. Look at that. I was so fancy, I even mixed and matched fractions and decimals. We're going to probably try to stick with fractions where possible. It's just a little bit classier in terms of your math format. But whether you do fractions or decimals really doesn't matter. And look at that. We got a negative answer. So what does it mean if it's negative? We're going to talk about that tomorrow. But for now, you just have to be able to do the mechanics. So let's try a couple more, and so we can see kind of how they get a little bit harder. So here in number 3, notice that you are trying to integrate the secant squared. Again, you offhand probably do not know the integration of the secant squared, but there's an app for that. There is a formula sheet. So you're going to go ahead and pull up your formula sheet. You're going to look under your trig integration, and here you have the integration of secant squared is equal to the tangent. So I'm going to go ahead and go back. The only integration that I need to do is to replace the whole secant squared with the tangent. Again, draw that fancy line to indicate that you know that you are now evaluating it. So as you go to evaluate, you are going to start with the top number, which means you are finding the tangent of pi over 4. Then you are always subtracting the bottom value when you plug in 0. So you're subtracting the tangent of 0. So again, at this point, if you were going to use your calculator, that would be fine. You would have to make sure that you're in radian mode. What I also have for you, if you look at the back, I have for you some of these important values of the unit circle, the quadrantals, and then the first quadrant. Hopefully you remember that as you go around the unit circle, the ordered pairs are the cosine sine. Hopefully you also remember that a tangent is a sine over a cosine, or a y value over an x value. The two values in question were pi over 4 and 0. So again, use the calculator if you want, but if you want to kick it old school, if you're trying to find the tangent of pi over 4, you would have to put root 2 over 2 over root 2 over 2, and anything over itself would give you a value of 1. If you were trying to find the tangent of 0, you would have to put the y value, which is 0, over 1, which would give you a tangent of 0. So those are the two values that I need. And again, find them here, find them on the calculator. It's up to you. But if you go back here to problem number 3, the tangent of pi over 4, that was 1. Then again, it's always a minus. The tangent of 0 was 0, and 1 minus 0 is going to give you a final answer of 1. So nothing is ever gone forever when it comes to calculus. We're always going to be throwing it back to old stuff. So that's kind of the reason why this practice day is so important. And then let's take a look at number 4. So here you're going from -8 to 8, x to the 1/3. So no rewriting is required. You just have to be a little bit careful with the fraction action. So you're going to go ahead and take 1/3 and raise it to the 1 higher power. So 1/3 plus 3/3 would give you 4/3. And then don't forget to divide by that power. So multiply by the reciprocal, you're going to get 3/4. x to the 4/3, and you're going to go ahead and evaluate it from -8 to +8. And then again, here's where you can either do it the long way or you can use your calculator. If you're going to go ahead and start by plugging in the top number, which is 8, you're going to get 3/4 times 8 to the 4/3. Then again, it's always a minus. Then you're going to do a 3/4 times a -8 to the 4/3. And then again, if you're going to use a calculator, that's just fine. If you're not, think about what you're actually being asked to find. 8 to the 4/3 means the cube root of 8 to the 4th power. So again, it hasn't been so long, hopefully, since you've done something like that. So the cube root of 8 is 2. 2 to the 4th is 16. So this is really 3 to the 4th times 16. 4 goes into 16 4 times, which means that's really 12. Then it's always a minus. The cube root of -8 is -2. -2 to the 4th is also a +16. The 4s will again cancel, giving you a +12. And here's an example where you're going to go ahead and get a final answer of 0. So again, I'm trying to show you all the extra steps, trying to remind you of all the calculations via calculator, just so that no matter what we throw at you, you'll be able to calculate it with very little issue. Just a couple left here, and we want to focus, again, on some of the important rewrite steps. So here in number 5, notice that you have 2 minus t times the square root of t. That looks like a multiplication. We do not currently have any formulas that allow us to integrate the opposite of the product rule. So that means we're going to have to go ahead and do a rewrite step. Remember, the rewrite step is sometimes the most important. So copy from 0 to 2, make sure you still have your integration symbol. If you multiply 2 times the square root of t, you're going to write that as 2t to the 1/2. Then minus, when you multiply t times t to the 1/2, you would add those exponents. So that would be 1 plus 1/2, which would be 2/2 plus 1/2, which is why you're going to get t to the 3/2. Only now, once you're ready to go ahead and integrate, should you get rid of the symbol. So leave the 2, 1/2 to the 1 higher power, which would be 3/2. And then you're going to go ahead and divide by 3/2. Minus t to the 1 higher power would be 5/2. You're going to go ahead and divide by 5/2. If you go ahead and multiply by the reciprocal, you're going to get 4/3 t to the 3/2 minus 2/5 times t to the 5/2. Just double check that I copied that correctly. So 4/3 t to the 3/2 minus 2/5 t to the 5/2 looks good. And then again, you're going to write that fancy bar there just to indicate that you're going to evaluate it now from 0 to 2. Here's the good news. When you have a 0 somewhere, more often than not, you wind up getting a value out that is 0, which is nice because it's just kind of a time saver. But you have to do the upper limit first, so you have to start by plugging in 2. So when you plug in 2, you're going to get 4/3 times 2 to the 3/2 minus 2/5 times 2 to the 5/2. Then again, it's always a minus in between terms. And luckily, I'm just going to get a big fat 0 when I plug a 0 in for both of these. This whole mess right here, these are not going to turn out to be nice numbers. So you don't really have to worry about keeping them as fractions. You can just go ahead and turn that into a decimal. You will have to do so on your calculator, which is why I reminded you how to do all those fractional exponents. And if you go ahead and go back and do it extremely carefully, you're going to go ahead and get an answer of 1.51 for your final answer here of this definite integral. So again, just to point out here, you're going to very carefully use the calculator. I'm confident that you could do it. If for some reason you're having trouble with that step or you need extra practice, you can ask your teacher to pause the video right now and do it, or you can ask them afterwards. But again, don't be afraid to use the calculator if the problem requires it. All right, we're down to our last two problems, and you're probably getting the idea by now, but we just want to show you again all the different possible ways you could be asked to calculate it. That way you get all the practice you might possibly need. So in number 6 here, we have 1 over 4x squared. That is not looking great in terms of how you're going to go ahead and integrate it. So I'm going to first go ahead and do a rewrite step. So I'm going to rewrite that as the integration from 1 to 2. I'm going to pull the 1/4 out, and I'm going to write it as x to the negative 2. And that's going to be a lot friendlier in terms of when I perform my integration. Now that I'm ready to do so, I'm going to go ahead and leave the 1/4. I'm going to take the x to the 1 higher power, which would be -1. I'm, of course, also going to divide by that power. When I go and simplify, I'm going to get a -1 over 4x. Again, we tend to put the negative sign in the numerator as opposed to the denominator, and then you want to get rid of that negative exponent. So -1 over 4x, that is my integration, and I'm now going to use the FTC to evaluate it from 1 to 2. You're, of course, always going to start with the higher limit of integration there, so you're going to plug in a 2. So that is going to give you -1/8. Then it's always a minus. You're going to go ahead and plug in the bottom number, so that's going to give you -1/4. If you want to go ahead and do it fraction style, you're going to go ahead and find a common denominator. So this is going to give you -1/8, and then minus a minus becomes a plus, and you would go ahead and write that as 2/8. So -1/8 plus 2/8 would give you +1/8 for your final answer. And if you made it 0.125, again, that would be perfectly fine. In some ways, the more things you put in the calculator, sometimes that can lead you awry. You can get the wrong answer. So if you're able to, manipulate those fractions, you might want to do it as long as it's easy. And then for something like the previous problem, certainly save the calculator for the hard ones. And then finally, here in number 7, you're trying to integrate 2 plus the cosine of x. And again, you are going to use your formula sheet for anything that you can't remember. So the integration of cosine, remember that is going to be a positive sign. So you're going to go ahead and integrate each piece. So don't forget to integrate first the 2. So how do you integrate a 2? It's a 2 and then a constant. You're going to integrate a positive cosine as a positive sign. So you need both pieces. And you're going to evaluate that from 0 to pi. You're going to go ahead, of course, and start by plugging in the pi up top. So if you go ahead and start by plugging in the pi up top, you're going to get 2 times pi, which is 2 pi, plus the sine of pi. Then again, it's always a minus. Your second calculation involves putting in the 0. So 2 times 0 is 0, plus the sine of 0. If you need to evaluate those sine values, again, you can either use your calculator or you can use this handy little reference that I gave you next door. Remember, the sine is the y value. So if you're trying to find the sine of pi, you're going to choose the y value, which would be 0. If you're going to do the sine of 0, you would choose the y value, which would be 0 as well. So here, you're going to get 2 pi. The sine of 0 is just 0, minus 0 plus the sine of 0 is also 0. You don't have to put all the zeros, but I'm just showing you what everything turns into so that you don't forget. Everything cancels out except for the 2 pi. So look at that. You can even get an answer that has a pi in it. Perfectly legal for that to happen. Remember, if you are going to use the calculator for your trig functions, just make sure that you're in radian mode because the majority of the problems do involve pi's. So you are now equipped to go ahead and do homework number 48. This is in the book, section 4.4. You're going to go ahead and do those problems. Each of those is a definite integral. So each of your answers should be a number. Please make sure that you show your work and use your calculator carefully. And just so you know, the problem says you should verify your answer with a graphing utility. You do not need to do that. I am confident that you are going to do it right algebraically, so no need to do that second step. So thanks very much for tuning in, guys, and we will catch you next time where we will talk a little bit more about what each of these answers actually represents.